Let's continue our discussion of the 7 basic common analytical tools of quality. The tools in this lesson are more matrix related and seek to exploit correlations between elements. Matrix diagrams provide a visual relationship between two parameters. Some examples of parameters include objectives, methods, results, causes, tasks, and people. These matrices help the team determine the strength of a relationship. A visual inspection of the interaction helps to localize where significant associations exist. The types of matrices include L-type, where elements are on the horizontal and vertical axis; T-type, where there are 2 sets of elements on the vertical axis, split by 1 set of elements on the horizontal axis; X-type, where there are 2 sets of elements on both the horizontal and vertical axis; Y-type, which consists of 2 L-type matrices joined along the vertical axis. All 3 sets are related, but 1 set is related to the other 2 sets in a circular manner. And finally, C-type. This also consists of 2 L-type matrices joined along the vertical axis, but the 3 sets of elements are related simultaneously. The strength of relationships are indicated by symbols or numerical values. Analyzing these strengths values can assist us in making objective decisions. Here are some visual representations of some of these types. For the L type, notice that there is only 1 space for a correlation. For the T type, there are 2 spaces for a correlation. For the X type, there are 4 spaces for a correlation. Here are visual representations of the rest of these types. For the Y type, there are 3 spaces for a correlation. For the C type, there is only 1 space, but note that this is a 3-dimensional space. Prioritization matrices help us identify critical few variables that need to be measured and analyzed. The statistical approach facilitates a focused data collection effort. These tools can also help us formulate theories about cause and effect. We use prioritization matrices when there are too many variables that might have an impact on the output of the process. We will also lean toward this approach when collecting data for all variables would cost too much time and money. Another added benefit is that prioritization matrices help to objectivize the analysis should team members have different theories about what happens in the process. The construction of a prioritization matrix follows these steps. First, list all output variables. Second, rank and weight output variables. Third, list all input and process variables. Fourth, evaluate the strength of the relationship between the output and input/process variables. This is the correlation factor. Fifth, for each column, multiply each weight by its respective correlation factor and sum to the right. This calculation works much like a weighted average calculation. Finally, highlight the critical few variables. Interrelationship digraphs are nothing more than cause and effect diagrams. In Course 5, we will dedicate time to cause and effect, or Ishikawa, diagrams. Interrelationship diagrams capture the interrelated cause and effect relationships in a problem. While the method is not as quantitative in execution, it is useful in grouping and analyzing the links between different aspects of a complex phenomenon.